Good day. Welcome to Phoenix Tutorials. In this video, we'll be talking about hybrid sequences, which are technically mixed sequences where you have an arithmetic sequence and a geometric sequence being presented to you as a unity. And it's important that as a grade 12 mathematics CAPS learner, you have to know how to navigate these types of sequences, and you have to know what to do as it relates to odd position terms as well as even position terms. And we can see here the odd terms belong to a geometric sequence, whilst our even terms belong to an arithmetic sequence. And over here, we can circle all of our geometric terms. Those are all the odd positioned terms on our sequence. And we can see that we do indeed have a geometric sequence where we have a ratio of 2. So the ratio would be 2 for that sequence. So now this video is all about helping you navigate these new sequences as well as to give you a way that you can find the formula for these sequences. Okay, so obviously the first part is identifying the pattern. So you'd have to see that on the first position I have a geometric, second position arithmetic, third position geometric, fourth arithmetic, and of course you'd have to use your formulae. So this is the formula for arithmetic sequences, for geometric sequences. Then we have the sum formulae, sum of an arithmetic and sum of a geometric sequence. Okay, so now we can see that for our odd positions, we have a geometric sequence. For our even positions, we have an arithmetic sequence. And we can easily find the equation of these sequences using formulas that we know. So we'll use all of those formulas for sequences. And moving on, we'll see that we can actually find the general term of the sequence. And in this case, we can see our odd positions give us a geometric sequence, 2, 4, 8, 16, 32, 64. So we can see here that we multiply by 2 every time. So our ratio is 2. Then we can find the general term. So the general term is A2R k minus 1. In this case, it's k minus 1, gives you 2 to the k using exponential laws over there. So we know that this occurs at all of the odd positions. So that will be a geometric sequence. So now you have to be careful with how you write the combined mixed sequence as write it into one formula. That's what we're going to do here. And what happens here is you need to divide by 0. So I'll use another color. So I'll use 2, 2. Then I'll go back to purple. So it's important that you guys understand what the formula is trying to tell you. So 2, 2, then we have a 4, and then we have a 9. So that's our mixed sequence. So now, how do I express two formulae, one arithmetic, one geometric, for this mixed sequence? And the way that we do that is we divide by 2. Because it's a hybrid sequence, we do that by dividing by 2. So we divide by 2 for odd positions, and we divide by 2 for even positions. So for hybrid sequence, you have to divide by 2, and it's much better to use the combined formula as opposed to looking at them as individual sequences, because that can get complicated. So it's a hybrid. If it's a hybrid, we'll divide by 2. So let's move on. So for now, if we do a quick recap, we have 2 different sequences, and we can find the formula for those 2 different sequences very easily using formulas that we know. But now, what happens in a mixed sequence? In a mixed sequence, you'll still find your 2 formulae, but now you will have an extra step of dividing by 2 because you're working with a hybrid sequence. That's the new sort of concept that's introduced. So now, instead of writing it as 2 to the k, I'll write it as 2 to the n plus 1 divided by 2. So why am I writing it like that? That's because in maths, an even number is defined as 2k. By maths, I mean pure maths on a global level. And an odd number is defined as 2k plus 1. So therefore, in this case, you have an odd position. We'll be dividing the odd position by 2. So you can see here the concept of a hybrid sequence that we have to divide by 2. And we define an even number by writing it as 2k, and an odd number in pure maths. If you study pure maths further in university, you'll see what I mean. But an odd number is defined as 2k plus 1 over 2. Therefore, in a mixed sequence, once you find the piece or the first occurring type of sequence, in this case geometric, you'll find the normal formula, but then you have an extra step of saying I have a mixed sequence. Therefore, I'll have something like 2. I'll use a different letter. They used N, let's use P. So I'll say I'm using P, it's a mixed sequence. And then I'm looking at the odd part of the sequence. I'll say P plus 1. Then I'll divide by 2 because it's a hybrid sequence. So that's how you sort of think about that. And does this work? Yes, it does work. Because if you look at this first term, if I plug in 1 over there, I get 1 plus 1 over 2. That's 2 over 2. That gives us 1. So that first term works. For the third term, I'll say 3 plus 1 is 4. 4 divided by 2 will be 2. That'll give me the second term of my, let me rather say it's G1, G2, the second term of my geometric sequence. So I have to use definitions for odd and even numbers in order to help me navigate hybrid sequences. And it's much better to write it as a modified or an edited formula where you respect the fact that it's hybrid sequence by dividing by 2. Okay, let's move on. So now we have even positions. So for even positions, we have our arithmetic sequence. We know that our A over here is 2. So just use your normal procedure for the sequence. A is 2. And we have A plus 1k minus 1d. We find our general formula for arithmetic sequence, and we have that general formula. But now we need to respect the fact that it's a hybrid. So we need to modify the formula because now you have, this is the first arithmetic term. This is A1. Then you also have A2. So now we have to find the general term. So we'll say this occurs at 2, 4, 6, 8. That's how even numbers are defined as 2k. So I'll say 2k divided by 2. So you can see here they're modifying it by saying that k gets rewritten as n over 2 because you're expecting that it's a hybrid sequence. So now if I had to rewrite this as, wrote it as in terms of p, p would be 7p over 2 minus 5. So now you have your general term of your sequence, and it has 2 pieces. One piece is for odd positions, one piece is for even positions. And now we can have a combined final rule for our sequence. So our final rule for our sequence would be defined as, so we call these piecewise functions. So if you do AP Maths or if you'll study Maths in university, you'll see functions being defined with this sort of bracket. And that means that it's a piecewise function, meaning that it has certain behaviors for certain values of x or for its domain. In this case, the domain would be the n terms for the sequence. And in this case, we're saying for n is odd, it has particular behavior, and for n even has another particular behavior. And we have to divide by 2 because the hybrid sequence, and you have to respect the definitions for odd and even numbers. In our next video, we'll actually talk about finding specific terms using those formula and finding sums. But for this short video, I want us to quickly recap hybrid sequences once again and not really overload you guys information. But just to recap, quick recap, a hybrid sequence is a sequence that's composed of 2 different sequences. And in this case, we had a geometric sequence for odd positions and arithmetic sequence for even positions. And in pure mathematics, I have a maths degree. So in the field of pure mathematics, we define an even number by writing it as 2k and an odd number, writing it as 2k plus 1. So for this purpose of hybrid sequences, we'll follow that convention by finding the formula for the geometric and rewriting it in such a way that we respect the fact that it's an odd number. So you have p plus 1 over 2. Then we also have an even number. We divide by 2 for the even number. That comes from the definition of even and odd. And why are we dividing by 2? It's because 2 sequences are sharing one house in a way. So you have to divide by 2 to make space for the other one. And we add 1 over here because we have odd positions. Okay, so now if you follow the notes, so here we have a given sequence. Have to identify the sequences, break them apart. That's what we did. We have G1, A1, G2, A2. And we can see geometric, arithmetic, and we can identify that it's a mixed hybrid sequence. Sometimes you might have a constant sequence, but we'll talk about that as another example. And then, of course, you find your general term for your geometric sequence. And since it's for the odd terms, you rewrite it in this new way where you divide by 2 and you add 1. So it's when n is odd, you have Tn, a new term for the hybrid sequence. That's how we move from k to n. It's 2 to the power of n plus 1 over 2 for the hybrid sequence. Then, of course, we can move down to our arithmetic sequence where we have a plus 1 or a plus k minus 1 d multiplied by d. In this case, our a is 2, our d is 7, so the difference is 7. 2 plus 7 gives you 9. That's 7. Then you find the general term. Then now you are moving on to this new world of hybrid sequences by saying that I divide my k by 2 because I'm working with even numbers. And then that brings us to the final rule of the sequence. And therefore, when you deal with these sequences, don't panic because you do have the tools to navigate them and you have been working with odd and even numbers for a long time now. And in an exam situation, you might get stressed out and not know what to do, but just calm down and break the sequence apart. Okay, so now we have our sequence and our final rule. It's a piecewise rule. So essentially, a hybrid sequence is what we'll call a piecewise sequence for n and even positioned terms, because essentially a sequence is a function because you have an input and you have an output, And you guys would remember in earlier grades, you learned about flow diagrams. That's what a pattern or a sequence is. You have an input and then you have an output, but now your input is just restricted to being the natural counting numbers. That's what a sequence is. You have natural counting numbers, excluding zero, of course. So now, if you're going to find the 12th term, I'll have to decide, is 12 odd or even? And in this case, 12 is even. So I'll say to find the 12th term, I'll just allocate it in the number system as even. So it'll satisfy this piece of the puzzle or this piece of the hybrid sequence in this case. Therefore, I can easily find my 12th term. Thank you.